Hey guys, it's a pleasure to welcome you to the final video in this first order differential equation playlist. And if you have made it this far, I hope the experience has been fun so far and you've been able to gain a lot of knowledge and you are quite proficient with the solutions of first order differential equations in various forms. Yeah. So without further ado, let's dive into this aspect of the applications of first order differential equations. So let's take a question. So a particle of mass m is projected vertically upward with an initial velocity v naught. And the resisting force to its motion at any time k is given as k multiplied by the velocity. So we are asked to formulate the differential equation and we are also required to show that the distance s in this case covered by the particle at any time t is given by s is equal to g divided by k squared plus v naught divided by k multiplied by 1 minus e raised to the power of minus kt minus g over kt. So this is a very interesting question and it's not so complicated. So now let's try to solve this question, and the first step is to understand what the question is asking of us. So now let's model the particle as a circle. So now we want to draw all the forces that are acting on this particle. We know that the weight of the particle acts vertically downwards. Likewise, the resisting force also acts downward. And there's also a last force that is acting on it, which is the net force acting on the body, because the body is moving vertically upwards. So let's label those forces. We have this to be equal to mg. If we let v to be equal to the velocity, Then we have the force acting against the body as kV, and we have the overall force F, which is the mass of the body multiplied by the acceleration of the body. So we have been told that the ball was sent upwards with an initial velocity v naught. And we can all imagine this, that if the ball is in motion and is going upwards, the velocity of the body keeps reducing from our laws of techniques or from our laws of physics. That the velocity of the body keeps reducing. This is due to the force of gravity and the possible force that the air exerts on the body. So the summation of those two forces, the weight of the body and the force of resistance offered by the air through which the ball moves or the particle moves, is going to try to reduce the velocity of the body. So this brings about a deceleration rather than an acceleration, or we can call the deceleration a negative acceleration. So this is going to form the basis for formulating our differential equation. Now we're told that the mass of the body is m, and the acceleration is a deceleration, which is the change in velocity divided by time. So we have that our force is equal to minus m dv dt. And what brings about this deceleration is the summation of the weight of the body and the resistance offered by the air. So we have that F is equal to mg plus kv. We have that minus m dv dt is equal to mg plus kv. On division or dividing both sides by m, we have minus dv dt is equal to g plus kv. So we can now collect like terms, bring all the terms involving v to one side and those without v to the other side. So we have kv plus dv dt is equal to g. So this can be written as dv dt plus kv is equal to g. And this gives the first order linear differential equation. So dv dt plus kv will be equal to g. We can get our integrating factor as e raised to the power of integral of k dt. This now gives e raised to the power kt. So the solution now becomes v e raised to the power of kt to be equal to the integral of g e raised to the power kt with respect to t plus a constant. So v e raised to the power of kt will be equal to g integral of e raised to the power kt dt plus c. And on integrating this, we have v e raised to the power kt to be equal to g over k e raised to the power kt plus c. Oh, I think a mistake has occurred. On dividing by m, this should be k over m. Should be k over m. Likewise, this should be k over m. So I'm just going to correct all of those. Then this will be g m over k, because 1 divided by k over m is going to give us m over k. So we write this properly. E raised to the power kt over m is equal to sorry, minus g. So a minus sign missing here. So it will be equal to minus gm over k multiplied by e raised to power kt divided by m plus c. So in dividing through by e raised to power kt over m, we have v is equal to minus gm divided by k plus c e raised to power minus kt over m. But this is just the first part that we have discussed. We still need to find the distance covered. So before we proceed, we're told that at t is equal to 0, v is equal to v naught. So we can substitute this from v is equal to minus gm over k plus c e raised to power minus kt over m. We have that v naught will be equal to minus gm divided by k plus c e raised to power 0. So c will be equal to v naught plus gm divided by k. Can now rewrite v as minus gm over k plus v naught plus gm over k multiplied by e raised to power minus kt divided by m. So we also know that the velocity of the body is the change in displacement divided by time, and from the question, displacement has been assigned s. So ds dt is equal to v, and this is equal to minus gm divided by k plus v naught plus gm divided by k multiplied by e raised to power minus kt divided by m. So you can apply separation of variables method here. We have ds to be equal to minus gm divided by k plus v naught plus gm divided by k e raised to power minus kt over m dt. So you can integrate both sides from here. On integrating both sides, we have s to be equal to minus gmt divided by k plus v naught plus gm over k multiplied by minus m over k e raised to the power of minus kt over m plus a new constant, let's say p. Or you can use any arbitrary letter. So we have that s will be equal to minus gmt divided by k minus mv naught divided by k plus gm squared divided by k squared multiplied by e raised to the power of minus kt over m plus p. So we know that at t is equal to 0, displacement is also 0. So we have that 0 is equal to minus mv naught divided by k plus gm squared divided by k squared multiplied by 1 plus p. So that means p will be equal to mv naught divided by k plus gm squared divided by k squared. And now substitute this into the original expression, and we have s will be equal to minus gmt divided by k plus v naught plus gm over k, sorry, mv naught over k plus gm squared divided by k squared e raised power minus kt over m. So this should be minus, not plus. So minus, then plus mv naught over k plus gm squared over k squared, which is the value we got for p. So this is common to both sides. We can factorize them. S is equal to minus gmt divided by k plus mv naught divided by k plus gm squared divided by k squared multiplied by 1 minus e raised to power minus kt over m. So this is the solution. But here we have been asked to show that s is equal to minus gt over k plus v naught over k plus g over k squared multiplied by 1 minus e raised to power minus kt. So let m be unity. That is, you're assuming m to be equal to 1. We have s is equal to minus g multiplied by 1 c divided by k plus 1 multiplied by v naught divided by k plus g multiplied by 1 squared divided by k squared 1 minus e raised to power minus kt divided by 1. So we know that s now becomes v naught over k plus g over k squared multiplied by 1 minus e raised to power minus kt minus g over k multiplied by t. And we've arrived at the solution as required in the question. Consider this matches with what we have: v naught over k plus g over k squared multiplied by 1 minus e raised to power minus kt minus g over k multiplied by t. So this is the solution for the question. And with this, we've come to the end of this video on vertical motion and also the end of the video series on first order differential equations. Thank you very much for watching, and see you guys in the next videos.